Alright, today we're going to talk about air masses and pressure system as well as fronts. We're talking about weather and climate in this unit. So the first thing I want you to do is write down two things you think you already know about weather and climate. You should know a few things. You experience weather every day. So pause the video, write down two things in your notes in OneNote and come back. Okay, we're going to continue today's class, our new vocabulary. Weather. Weather is the state of the atmosphere, like temperature, the moisture, wind, etc., at any particular point in time and location. So what is the weather out today? Today it is cold and rainy, or today it is hot and humid, or today the sky is clear, sunny, and 73 degrees, okay? That is the weather. So the weather in Houston today is cold and dry, okay? But the climate is the average weather over a long period of time. For example, the average weather of Houston would be more, the climate would be more like, oh, Houston is kind of hot and humid. So if anybody asks you, you would say, oh, Houston is hot and humid. You wouldn't necessarily tell them the weather today. You would tell them in general, how is the weather in Houston, meaning the climate, the average weather. Most people use these words interchangeably, okay? And in Spanish, weather is similar to climate, but in science we separate the meaning of the two words, okay? Air mass. An air mass is a body of air that starts in one area and carries with it temperature and moisture levels of where it started. So if a air mass starts over the Gulf of Mexico is wet and hot. So it would be the air mass that comes from the Gulf of Mexico to Houston, Pasadena area, the air mass will carry with it hot air and wet air because it started over the ocean. The ocean is made of water, so it's wet, and it's a tropical area, so it's warm weather. So the air masses move air in types of air. All right, fronts. A front is the boundary separating two air masses with different properties. So we're going to show you the symbols for fronts, and a cold front replaces cold air mass can replace a warm air mass, and then that line in between would be where the front is, and we'll see symbols for fronts for weather maps when we look at weather maps shortly. And pressure systems. A pressure system is an area of the atmosphere with high or low pressure. So pause the video, take down your notes. Alright, so let's look at air masses. Air masses. An air mass that start over oceans have high moisture levels, and air masses that start over land have low moisture. High moisture levels would be air masses that start over the Gulf of Mexico. Low moisture levels would be air masses that start over the central part of the United States or in the middle of Texas. The closer to the equator an air mass starts, the warmer it will be. And the closer to the North Pole or South Pole, the air mass, the cooler the temperatures will be. Alright, that's obvious. If it's air mass comes from Canada, it's going to be cold. If the air mass comes up from Mexico, it's going to be a little bit warmer than the air we already have in Houston. Alright, fronts. Warm fronts bring warm temperature and usually rain or thunderstorms. So a warm front looks like this, with little sunrises coming off the line. Alright? A cold front brings cooler temperature and sometimes rain or thunderstorms. So here is a cold front. Let me draw it over here. There's going to be little triangles or icicles. Okay? So if they have little icicles for cold front and little suns for warm front is an easy way to remember it. And remember, on testing, it probably won't be in color. So you need to know that the shapes are different between a warm front and a cold front. So stop the video, take your notes. Alright, high pressure versus low pressure. So a high pressure system is drawn with a big capital letter H, blue, and a low pressure system is drawn with a capital letter L, red. Something just happened. Just take that back. Okay? In red. So high pressure systems bring cooler, dry, good weather. Smiley face. High pressure, like when you're feeling high, happy. Alright, H is for happy, happy weather. Alright, good weather. L is for low, when you're feeling low, when you're feeling down. Bad weather, sad face. Alright? Oh, he's sad. Looking a little bit mad now, but sad. Alright, so let's watch a short little brain pop, or not the whole brain pop, part of it.
Oh, right, air pressure. You might not realize it, but the air around you actually has a weight. We measure air pressure with a device called a barometer. In areas of high pressure, air slowly descends toward the Earth's surface.
So it's
High pressure areas are associated with clear, sunny days.
Clear, sunny.
In areas of low pressure, air rises upward into the atmosphere. Low pressure areas bring high humidity, clouds, and, you guessed it, rain and other precipitation.
Rain, bad weather.
When you look at a weather map, you'll see all the different areas of high and low pressure marked with big H's and L's.
Red.
These air masses are constantly
blue,
moving around. A high pressure area that's over Ohio on Wednesday might be over New York City on Thursday.
Moving.
The boundaries between these air masses are called fronts, and that's where heavy storms and other serious weather can take place.
Yeah. We didn't need to watch the whole thing. Alright, so effects of oceans on climate. Cities that are near the ocean have slightly different climates than inland cities at the same latitude. So two cities can be at the same latitude, but have different types of weather because one is closer to the ocean, one is further away from the ocean. Coastal cities usually have warmer winters and cooler summers compared to inland cities. So why would a coastal city, a city by the water, have warmer winters? Because the ocean temperature doesn't change that much. Remember in the lab, the sand versus the water temperature changes? The sand got really hot really fast and cooled down to a really low temperature really quickly. While the water, even after the same amount of time heating, the water temperature did not change that much. Well, that's the same thing that happens with the ocean. The oceans around cities stay around 80 degrees all year round and just change very little bit. So in the winter when the land is really cold, the water, the oceans are warmer, making cities near the warmer water warmer during the winters. And during the summers, when the city would be super hot, the oceans are still 80 degrees, which is a nice temperature. And it cools down the cities during the summer. So living by the coast, like if you live in San Diego, California, or in Galveston, the temperatures are much more mild, not too hot and not too cold because of the effects of the temperature of the ocean not changing that much during the summer and during the winter. Alright, so let's look at some combinations of air masses and what they could be. So air masses, you have maritime air masses that start over the oceans and they're wet and they start over the oceans. Continental, they start over land, like start over Canada, start over Mexico, and they're dry. Why? Because land is dry. Maritime oceans are wet. Polar, it's going to be cold. They're going to be away from the equator. They're going to be at the North Pole or at the South Pole. Okay?